Hey everybody, thanks for joining us today for our second quarterly HEC HMS webinar. My name is Mike Bartles and I'm the current HEC HMS team lead. Over the past year, the HMS team has added a slew of GIS features aimed at making model development faster and more efficient. In this webinar, we're going to cover some of those new features through demonstration, in addition to a brand new automatic forecasting utility. So the speakers for today are Tom Brower and Josh Willis. Tom Brower is the lead developer of HEC HMS and has been instrumental in nearly everything HMS related over the past few years. So we've made 8 releases of HMS in the past 12 months, and you have Tom to thank for that. Josh Willis is the newest HMS team member, having come to HEC from the Fort Worth district about 2 months ago. If you enjoy the build walls, burn streams functionality, or enjoy having the ability to compute sub-basin or reach characteristics within HMS, thank Josh because he added those. So I just want to let everybody know that we're recording this webinar, and we're going to post the video to our website soon. Everybody should be on mute. We're going to try to minimize disruptions. Please type your questions in the chat, and we'll either answer them there or we'll get to them at the end. So without further ado, I'll pass the mic to Tom and Josh.
All right. Thank you, Mike. As Mike said, this is the HEC HMS Quarterly Webinar, and we're trying to do these once a quarter. This is the spring quarter. It's our 3rd quarter in our fiscal year, but it's spring in California, and I took this picture last weekend. I'm trying to do seasonally appropriate pictures on our title slide. But by looking at the picture, you might not know what season it is. It kind of looks like it could be winter, spring, or fall, not really summer looking out. But anyway, that was last weekend. This is the East Fork of the Carson River in Nevada. I did a little kayaking trip, and I think at one point we were getting something that was pretty close to snow on us while we were in the river. It was either sleet or snow, something frozen. I'm from Florida, so I don't understand these frozen precip tights, but anyway, very fun. The river's a little low. We're running low on snow this year. The snowpack's nearly gone. All right. First order of business, HEC Geo HMS is no longer supported. I don't know if you've picked up on the trend as of the past 4 or 5 releases since 4.4. A lot of the GIS functionality that was traditionally in Geo HMS is now in HMS standalone. And with the most recent release, version 4.8, that included the terrain reconditioner, we decided that there was everything you needed to do in HMS itself to do your GIS processing. So as of that release, we decided to go ahead and put the notice out. We're officially ending support for Geo HMS. One of the biggest limitations of Geo HMS, if you didn't notice from using it over the past couple of years, not necessarily that it was buggy or had bugs, was really that it wasn't serviceable. So the code was just in this place and state where we couldn't really do a whole lot to service it, and that was one of the most troubling things. So if you noticed, if you reported a bug or came in with a bug, it was often a redo or a workaround. It wasn't really like, oh, hey, we fixed that just because we couldn't. We didn't have the source code and things like that. So now that all of that code is living in HMS, it makes it a lot easier when you come to us with a bug for us to fix it, turn it around in a beta release or a release, and have an improved product. So that's one of the things I'm most excited about the new GIS features in HEC HMS. Now for you, the user, there's many benefits. I think the most helpful thing is the feedback loop has become a lot smaller on having a project, deciding that you need a delineation or a merge, a change in your basin, and being able to do that right there in the program without having to do that full feedback loop back over to Geo HMS and then bringing it back into HMS. So I think this will improve your workflow if something does need to change in the delineation. So that's that. There's the notice. And then from there, what we're going to do today is I'm going to demonstrate the current state of affairs in HMS, what delineations look like. We're going to go over the terrain reconditioner that Mike mentioned earlier and that Josh added. I'll show you a little bit about that. And then another cool new feature about the latest release, or actually it's not the latest release version, it's the latest beta version, is a multiple sub-basin merge, which I think will speed up GIS processing, so I'll demonstrate that as well. So here are the steps. Generally, we're going to create a new project, import a terrain, create a new basin model, and link that terrain to it. We're going to run some terrain processing from the GIS menu in HEC HMS. We'll import breakpoints that'll split the subbasins where we want them. Then we're going to do the delineation, and then we're going to compute a discretization. So with that, I'm going to close the slideshow, and then try to close the slideshow, and then do a little demonstration in HEC HMS. I'm going to start from scratch. Hopefully that's helpful for you just to see me go from nothing to something. So I'm going to start by going to File, New, and I'm going to create a new project. We're going to be in Denton Creek today. This is a headwater subbasin of the Trinity River. It'll make the auto forecast that we do at the end a little more interesting because I've heard there's some precipitation happening down in the Texas area right now. So I've just named my new project, Denton Creek. I've put a location. I'm going to use the U.S. customary unit system. So I've created my HMS project. One thing to note, this is a directory on your computer, so I put it in C projects. I named it Denton Creek. Here it is on my computer. I'll try to show you as we go through where some of these files are being created as we do the GIS processing. So next thing to do is create terrain data. So I'm going to go to Components menu, Terrain Data Manager, going to select New. I'm going to name my terrain data NED 10 meter. This is the data source for my terrain data. And then I'm going to reference a GeoTIFF file. And before I do that, I'll just bring over Qgis and show you a little bit of what that looks like in a GIS. So this terrain that I'm referencing that I'm going to import to HMS is right here. Qgis is just a GIS like many users might use ARC products. It's very similar to that. It's just open source. So that's all that is. And then the TIFF I'm referencing is this one behind here. And I believe if we don't have one already, very soon we'll have a tutorial and guide on how to create this TIFF, kind of like I have here with buffering around my anticipated area of delineation. And then things like, since we're working here in the U.S., I've moved everything over my vertical units to feet, things like that. So I don't think we have one right now, but soon we'll have a tutorial and guide that will walk through how to prepare your raster for import. So that's the file that I'm going to reference. So it's called dentoncreek.tiff. And my vertical units, like I said, I already moved that over to feet. So I'm going to change the vertical units to feet. And so now I've created my terrain data. The next thing I'll do is create a basin model. I'm going to name my basin model Denton Creek. I've created the basin model. And now what I'm going to do, I'm going to navigate to it in the tree, and then I'm going to reference the terrain data that I previously imported that's called the NED 10 meter, National Elevation Data Set 10 meter resolution. And now I'm going to hit the Save button here. I'm going to be prompted on a basin model coordinate system, and I think one of the ways that we often do it that I think is the smoothest is to already have that terrain data in the projection system. Coordinate reference system that you're planning to use. So I can, because I did that already, I can just hit skip here. If I hadn't done that, I could select it, but I'm going to skip that step so it will adopt the coordinate reference system of the terrain data. And you can see it's now come into my basin map. And if I go to the GIS menu, I can take a look at the coordinate system here. And I reprojected it into the Albers equal area conic, which I can tell here from the well-known text string that that is indeed the coordinate system of the basin. All right. So one thing I'll say, I talked a little bit about, I showed you the data in a GIS. Where did I get the data? So in the U.S., the source that we often use is this National Map Viewer. And I've zoomed in here to the Dallas-Fort Worth area. And you can see Grapevine Lake here. You can see Denton Creek here. And I can go through some selections to select that data product. Right here, it might come in 2 or 3 rasters, or it could be even more than that if you're in a really large basin. And so I had to do some processing in the GIS to get it ready for HMS. And like I said, that tutorial is on its way. So that's the National Map Viewer, a great place to go get the data. All right, so next step, I'm going to show the terrain reconditioning. So you see on the next step down on the GIS menu, terrain reconditioning. First step is to build walls. And terrain reconditioning, we typically build walls and burn streams. Those are the traditional operations. And to demonstrate what exactly is happening there, I pulled up a slideshow that's actually in our basic HEC HMS class. I think it's a great illustration of what's happening with build walls and burn streams. And let's see. Yep, so there'll be a link at the end of these slides that shows where to find all of the material from our basic HMS class. And like I said, this is just one of the slideshows from that class. And I think it's really helpful. We talk about building walls and burning streams. We also talk about a smooth drop and a sharp drop. And with the smooth drop, you can see here the smooth drop buffer is 2 cells, and you can see that a smooth drop has been created. When we're talking about a sharp drop, it's literally the cell that's underneath whatever polylines I have. And then we can combine a smooth drop and a sharp drop. Let me show the combined. I minimize that too soon. So this is a combined smooth drop and sharp drop. We have a smooth drop here with a buffer of 2 cells, and then we have a sharp drop of 1 feet that's just directly underneath this line. So this is in a section view. Let me show you in a plan view really quick what that looks like before I do this operation. So this, like I showed earlier, I have my raster here, and my build walls. I'm going to build walls based on these HEC 12 boundaries that you see here. So I also got those from the National Map Viewer, and those are just the HEC 12 boundaries. So that's just a level of delineation of a basin. And then for burning streams, I'm going to use these NHD flow lines that you see here in blue. And so this just corrects the raster. It reinforces where the streams are and where the boundaries of the subbasins are. I'll say now that you don't necessarily need to recondition your terrain all the time. Actually, I think in most cases, you would probably get the same delineation one way or another, especially in a case like this where I can tell there's a pretty good amount of relief in the basin. Places where I think terrain reconditioning is really helpful is one, if you're in a flat topography. So those modelers in Florida, Texas, Southeast Texas, and Louisiana, yeah, terrain reconditioning is going to be especially helpful for you. But another place I think that this is helpful is if you're using a very coarse raster resolution, which is encouraged, it speeds up raster processing time. So if you're using a very coarse raster, you can force the boundary a little bit by using these terrain reconditioning steps. Like I said, I don't know that it's necessary for this data set that I'm using right here, right now, today, but I'm going to demonstrate it just so you can see what it looks like. So like I said, I'm going to use that HEC 12 for my boundary. And for the raise buffer, I'm going to use 1 cell. And then the smooth raise height, I'll use 20. And then the sharp raise height, I'll use 10. And then for burning the streams, I'm going to use that NHD flow line layer. I'm going to use a drop buffer here of 3, a drop height of 25, and a sharp drop of 10 feet. If I said meters earlier, I apologize. It'll be in whatever unit system you consider your vertical unit system.
Well, that's going, Tommy. I got a question for you from Ruben.
Sure.
He was asking if there are any recommended coordinate systems to use, or are there any coordinate systems that may not work so well with HMS? Yeah.
I know the MMC at some point, which is in USAC modeling mapping consequences, determined that the Albers equal area conic is ideal for those MMC studies, and it has kind of permeated USACE. So it's the projection that we use most commonly. It's area preserving, which is good for volumetric computations. And then if you're international, we highly encourage the UTM. We've put a lot of tooling around those UTM coordinate systems. I'll say that HMS has been built in a way that you can potentially use anything, and you can mix and match, your precip with a Basin model that's in different coordinate systems, and it's getting more and more flexible. I personally like to just stick with one coordinate system throughout to eliminate any potential discrepancies when it comes to reprojecting things. So for CONUS SHG, for CONUS USACE projects, SHG is a good one to use, which is what I'm using here. All right, reconditioning is complete. Let's zoom in and take a look at what this looks like. And this is subtle, so I will do my best to make this large so you can kind of see here what a reconditioned terrain looks like. I just expanded this a bit. I'm going to open the map layers dialog, which will help here, and I'll keep this open or try to remember to keep it open. And I'm going to toggle on and off reconditioned terrain a few times, so hopefully you can notice the differences. First thing I'll say, right now we're looking at that reconditioned terrain layer, and I can already see that wall that we built here. And I can see here's the wall coming in for a sub-basin right into the interior of the drainage. And then I can also see that these streams are pretty well defined. So we burnt in those streams, and you can see the definition. Now I'm going to turn that off, and you'll notice that the lines become a little more blurred. The wall that we put around the boundary is less obvious, and then the burn lines that are in the stream network are less clear. So, like I said, it may not be necessary in this case because there's so much topographic relief, but in flatter basins or in areas where we're using a very coarse grid cell size, this is really helpful to recondition the terrain. All right, so that's terrain reconditioning. I'm going to move on to pre-processing sinks. So for all of the hydrologic algorithms, it's important to have a sink-filled DEM. So we go around to all the low spots in the raster, and we're going to fill it in. And this is necessary for the next step that we're going to do of flow direction and flow accumulation. So you see there's two more layers that have been added to my map layers. One is the sink locations, one is the sink fill. And I can toggle those on and off. And right now we are looking at the sink locations. All right, now that we've gone through that step, I'm going to move on to pre-processing drainage. And what this does is it gives a flow direction grid and a flow accumulation grid. And what are those? Well, let's take a look at flow direction first. So for every grid cell in the raster, now that we've filled in all of the sinks, the water can flow in one of 8 directions. I'm zooming in here. And so the 8 directions are north, south, east, west, and then the directions in between, so northeast, southeast, southwest, northwest. And so those, given a single grid cell, the flow goes in 8 directions. And using that, we can that sets up things like we're going to show in a bit, delineations and splits and stuff like that. So that is the flow direction grid. Let's turn on the flow accumulation grid. So now this shows the accumulated flow to each grid cell. And what I can do here is I can hover over any grid cell and see how many grid cells are upstream. So somewhere here that looks like there's 2 or 3 cells upstream. But if I go towards the main channel, I should see more accumulation. Like that has 584,000 cells or so upstream. And so that's what a flow accumulation grid is. And once again, that's going to help with some of the subsequent processing steps, what that gives us. All right, I'm going to turn that off. We're moving our way right down this GIS menu. This next step is called Identify Streams. And part of the Identify Streams is to parameterize or enter a threshold to define the streams. So I just showed you the number of the flow accumulation, how many grid cells are upstream of a particular cell. Well, this area to define a stream, we had it count with the flow accumulation grid, so a number of cells. If you do a little math and you know the size of the cell, then you can determine number of cells times size of the cells is an area upstream of the cell. And so if that area is greater than this threshold, then that's going to be defined, that's going to become a stream. So if you use a very small number, you'll notice that the streams go way up into the headwaters. If you use a larger number, the streams aren't going to happen until lower in the basin. I'm going to use 10 in this example. That's not 10. That is. I'm going to use 10 square miles for my threshold in this example. And so you can see this network of streams was created using that 10 square miles as the threshold. Where this comes into play, it comes into play in the delineation step we're going to do, and I think 1 or 2 steps. And so the coarseness of the delineated subbasins, the fine or coarse nature of those is going to be a function of what we used here of defining the streams, the threshold to define streams. So that's identified streams. The next thing that I'm going to do is I'm going to bring in some breakpoints so that we can get to delineation, because we want to do our delineation based on breakpoints. And one of the new features that just was added in the most recent beta is the import option. So I'm going to use this import option. I went to GIS menu, Breakpoint Manager, Import. And now I have a gauges layer. Let me show you that in the GIS. Here's my gauges layer. I have 2 gauges that came in from a USGS shapefile, and that's where they are. So what I'll do is I'm going to point HMS at those gauges, and there's my 2 breakpoints. So those came in. One thing about breakpoints is they have to be on top of that identified streams layer. And I'll zoom into this one so we can see it's right on top. And that's one of the nice things that this import functionality does, is it snaps the breakpoints to the identified streams layer, if not already on top of it. So sometimes a gauge might actually show up in a GIS somewhere like here. So that import option is also going to snap it to the stream, which is helpful. So I've imported the 2 breakpoints, and the next step is going to be a delineation. So I'll select delineate, and then I have a little dialog here where I can provide some prefixes. When it delineates, it'll auto name it. I'm going to leave those blank. I am going to insert junctions, and I'm going to leave that as is and go ahead and delineate. All right, there's my delineation, and you can see that it forced the delineation at the breakpoints, which is helpful. And I used 10 square miles for that threshold. So what I want to do now, that's a little bit finer resolution than I planned on for this basin. I want to say, I can't remember exactly, this is like 500 to 700 square miles. I adopted this from Josh, who was from the Fort Worth district, so not my native territory as far as modeling. But anyway, I'm going to go a little bit coarser on these subbasin delineations. I'm going to get down to about 3 subbasins, and I'm going to do that by merging. So I'll just start in the headwater here, and I'll select a few subbasins to merge. This is going to be my headwater subbasin, and I'll go ahead and merge those. So like I mentioned earlier, in previous versions of HMS, the merge was limited to 2 elements, and now you can do multiple elements. The one thing that I'll say is important is that the elements have to make sense hydrologically. Let's do a few more merges and then I'll show you that, because if the merge does not make sense hydrologically, it'll be blocked. It's important to find little subbasins like this that might block a merge but do exist. I got the reach. Let's try and get subbasin. Got the reach again. It's a tough one to get. See if that does it for me. Yeah, there we go. Okay, so I got that middle subbasin merged, and I'm going to do 2 more here. I'll merge these. All right, I've merged my subbasins. In the middle of my basin here, these reaches should probably be merged, and I can do the multiple merges for reaches as well now. So I want that all to be a single reach. So I've merged that, and then down here, there are two reaches that I'm going to merge together. All right, good deal. So what I was talking about mergers that don't make hydrologic sense. So if I were to try to merge these two, yeah, that seems legitimate. I should be able to merge those. But if I were to try to do something like merge this and this, see how there's a subbasin in the hydrologic order? That's going to keep those two, prevent those from being merged. So if I go to the merge here, we should see that rightfully this is now blocked. I can't merge these two subbasins. So if you're doing multiple subbasin merges, keep that in mind. If something's blocked and you don't think it should be, either let me know or take a closer look. I would do an inspection to make sure there's no small subbasins or something you weren't thinking about that's hiding out there in the hydrologic order. So that's that. The last thing I'm going to do is I'm going to show a discretization. We talked about discretizations in the last webinar that we did. That was the winter webinar. And so you can learn a little bit more about it there, but I'm going to go through it pretty quick this time. So I need to change the discretization for all of my subbasins to, I'm going to use a structured. This is going to default to SHG 2000 meter. And what I do, we set the discretization from the parameters menu, but to actually compute that, that's a GIS task on the GIS menu. So I've gone to GIS, compute, and I'm going to do grid cells. This should compute. The discretization layer that defaults to off because often you don't need it on for most of the time that you're doing modeling. So it defaults to off. But if we want to come take a look at what our discretization looks like, I can come enable it here in the map layers. And this is what a 2,000 meter grid cell resolution looks like over my basin. I'll turn that back off. All right, so I'm going to go back over to PowerPoint and do a little recap, and then I'm going to pass it off to Josh, who's going to talk about characteristics. All right, so the key points that we hit, HEC Geo HMS is no longer supported. Use HEC HMS. So you can use Geo HMS. I'm not going to tell you you can't, but if you have any problems, don't come to me, I guess is the moral of that story. So, like I said, I can't do a whole lot to fix Geo HMS, but we can do things to fix or improve what's in HMS, and we think it's in a pretty good place right now. Another point I might not have made mention of, but in detail, but high-resolution terrain data is a common pitfall. So a lot of people come in with very high-resolution data, like things like LiDAR, and it's not necessarily needed for hydrologic modeling. All we're trying to do in hydrology is get that basin outline, which you can often do with way more coarse resolutions than LiDAR. So reasons you might need LiDAR are pretty much limited to like a 2D overland flow transform type compute. That's a use case for LiDAR. But in general, and I think my coworker / supervisor Matt Fleming is actually working on a great tutorial that's going to go through different resolutions of rasters and demonstrate, what the process raster looks like, the amount of time to get to the process raster, and show some of the discrepancies between the delineations with different grid cell sizes. And I think the one thing that we'll see from that example is that you're going to get pretty similar results, regardless of the resolution. And then the new import breakpoints option is a fast way to import breakpoints. And so that shapefile or that layer that you import from needs to be points. It's only going to import the points if they're lines or polygons or something like that. It's just going to ignore them. But the other nice thing about that is going to snap those to the identified streams layer. And then the new 2-to-many, so it previously was 2, now it's 2-to-many merge elements capability, makes merging elements much faster. So you saw I kind of started out very high resolution on my subbasins, and then I went to a more coarse resolution through merging, because merging is, now I can do a bunch of elements at once. So that's that. Last thing I'll show you before I hand off to Josh that I didn't in the midst of going through those rasters is where those actually live in the project. I showed you what the project looks like on your machine. I saved mine to C project Denton Creek. And if I go to this GIS subdirectory, and then I go into the basin, so the name of the project is Denton Creek. The name of the basin is also Denton Creek. So this is where you might see several basins if you had more than one in your basin in your project, but mine's named Denton Creek. If I go in there, I can start to see all of those rasters that were created as part of the terrain processing process, or the GIS processes. So those are there if you wanted to pull them into a GIS and take a closer look. But they do display an HMS on that map layers dialog. All right, so with that, I'm going to hand off to Josh, who's going to go over characteristics.
All right, thanks for that, Tom. See if I can share my screen here quickly. All right. Can you see my screen and hear me okay, Tom?
Yep, you're good.
All right. So I'm going to pick up right where Tom left off. So, you know, Tom built the basin model, and he delineated the basin elements. And now kind of the next logical step would be to go through and to start parameterizing some of the methods that we want to use in this model. So I'll start off by talking about the subbasin and reach characteristics. And I'll show you guys how you can use characteristics in tandem with grids that you can port into HMS to help quickly populate these parameters and get you on a good step, hopefully getting you quicker to being able to get into calibrating your model. So with that, I'll go ahead and jump right back into the demo. And again, this is kind of where Tom left off. One change that I did do was I went and I renamed some of the elements here just to make the names a little bit more meaningful. But I'll come up here to the Parameters tab, and then underneath Characteristics, we'll go ahead and compute subbasin characteristics. So the first time that you access this table, these characteristics will be computed on the fly. And you can see we have about a dozen or so different characteristics, different sorts of flow paths and slopes and ratios and whatnot. And these are kind of some of the standard ones that you would find in a lot of literature. We do have a video that kind of goes into each of these and defines them and shows what they are, and they're pretty well covered in the user's manual. If any of you find a characteristic that's not included, that you would like to be included, please definitely let us know. It shouldn't be too hard to get those added. So I will say that you can edit this table. So if for whatever reason you want to manually enter in some numbers, you can do that, hit apply, and then these numbers will be used for the expression calculator, which I'll show you guys here in just a few. And then maybe if you decide to go back to the GIS menu, and let's say you decide that you want to delineate this watershed with 3 subbasins instead of 4. You can go and do that, make any other changes, and then when you come back to this table, you can just hit recompute, and these values will be recomputed based on the latest GIS data that's available. So similar to subbasin characteristics, we also have reach characteristics. So we'll go ahead and compute those really quickly. And I did notice a question in the chat was about ways to view these different types of flow paths that are being computed. So I'll show those off really quickly here. So I'll zoom in the map window, and when I computed subbasin characteristics, several different layers were automatically added to the mapping here. So I'll turn some of these off to make it a little bit easier to see. I'm going to turn off centroidal flow paths, centroid, and 1085, and I'll turn off discretization too. And it's kind of hard to see, but right here in kind of this purplish pink color is the longest flow path. And these are computed for each subbasin. And this is just a good kind of simple check that you can do to make sure that, you know, these characteristics are kind of being computed as you would expect, given the watershed that you're analyzing. There are essentially two ways that you can export a lot of this GIS layer data, that you're visualizing here, and so I'll show you those. Probably the most applicable to most users who like to use ArcMap would be to come in here and do the Export Layers option underneath the GIS menu. We've recently added some more layers here that you can export. One of the big ones was junctions. Several people on Discourse mentioned that it would be helpful for them to be able to export this data, so that's here. And so anything that you see here can be exported as a shapefile, and then you can view it in whatever GIS software that you choose to use. Speaking about junctions, I'll mention one tool that was added a version ago, and that's the Snap to Downstreams tool. So sometimes when you get to panning around in this model, you can accidentally move basin elements around. And so prior to exporting junctions, I would recommend coming into the map pane, right-clicking, and then doing a Snap to Downstream. And what that'll do is it'll take all of your junctions and snap them to the closest end of the downstream reach that the junction is connected to. And then once you get everything kind of set up how you want it, you can always right-click on your basin model and then do lock element locations, and that'll keep things from being shifted around. So GIS export layers, that's one way, probably the easiest way for most. But another way that you can kind of crack open some of these GIS layers would be to look at the Basin SQLite file. So I'll show where that is. So this is the main project directory that we're working out of for this demo. And each basin model will have its own SQLite file. And that's where a lot of the geospatial layers live within this file. And so I have QGIS open. As Tom mentioned, this is just kind of a complementary software, very similar to ArcMap. It is available on the app portal. And I've found for viewing SQLite data, it's much easier. So I'm just going to simply drag that Basin SQLite file, drop it into QGIS, and I will plot up just a few of these layers that are in this file so we can take a look at them. And there we have it. So we have our centroidal flow paths that were calculated for each of the subbasins in our model. We have the centroid at each subbasin, and then obviously the subbasin layer as well. I do think that you can visualize SQLite in Esri products, but it's not seamless. I think you have to do a little bit of finagling to get that set up. All right, so with that being covered, let's go ahead and quickly parameterize our model here. So as Mike mentioned in the beginning, kind of the end goal here is for us to have a continuous simulation model that we can use to demo the auto forecast option that Tom built. And so we do need a canopy method. So we'll use this simple canopy method for this demo. So bear with me really quickly while I go ahead and fill this out. This will basically allow us just to have a method for extracting moisture from the soil. Get these as well. Okay, and we'll move on to the next one in line, which is loss. And so on this loss global editor for deficit and constant, you'll notice a button here at the bottom of the window called Calculator. So I'll click on that, and it launches an expression calculator. And these expression calculators have been built into several global editors within HMS, and hopefully more to come pretty soon. But what these do is they access two sources of data. So number one, they will access any parameter grids that you might have previously imported into HMS. If you're not familiar with that process, we do have a video and tutorial guide that outlines that. And then secondly, it accesses any characteristics that you might have computed for your basin model. So for this deficit and constant method, I am going to choose 4 grids that I have created in ArcMap and have imported into HMS. And these grids were created from, let's see if I can pull that over here real quickly, from a data set called Surgo. It's basically a big soil survey database. It's put together and kind of maintained by the NRCS. And I downloaded data for the state of Texas, a bunch of soil data, clipped it to the watershed, the Denton Creek watershed here that we're analyzing, did a few table joins and some geoprocessing within ArcMap, and then created these grids that are going to kind of help me quickly parameterize this model. And so we'll start out with initial deficit. So I have that selected here in the expression calculator. I will double click on my initial deficit grid. It populates the equation box down here, and I'll go ahead and hit calculate. And you'll notice that it went ahead and quickly populated the initial deficit parameters for each of the 4 subbasins. And so what it's doing is it's taking those grids and it's kind of averaging all the values that fall within a subbasin and then applying that in the global editor table. So I'll quickly do the same for the remaining 3 parameters. So we'll do maximum deficit, choose that, hit calculate. Our constant rate. And our percent impervious area. And there we go. I'll accept those changes. And you know, this is kind of a dinky 400 square mile watershed. You know, there's only 4 subbasins, and so we could have probably quickly entered these in via hand. But the power of this, I think, comes when you're working on some of those larger watersheds, you know, where you have hundreds, if not more, subbasins that you're trying to, you know, estimate different parameters for. And so this is I think, a real game changer in terms of quickly being able to parameterize even a large model and getting ready to, you know, getting kind of a good first guess of parameters before you go into calibration. So similar to that, we're going to also use the expression calculator for Mod Clark. So I'll launch that. And this time we're going to use some of the characteristics that we have computed previously. And so you can select these, enter in any sort of equation. You know, if you have a regression equation for the watershed that you're analyzing, you can enter that in here. Or if you have a regression equation that was developed maybe on a different watershed, but that's similar to yours, this would also be a good spot for that. I have, oopsie daisy. I did have an equation here to populate this time of concentration box in, but it has disappeared on me. I was just going to copy and paste because it does take a little bit of time to kind of choose your values and get them entered here. Just for example purposes, I'll do something silly, and I'll say that my time of concentration is going to be longest flow path length divided by 2. Show you how this tool works. I'll enter calculate, and it parameterizes time of concentration. And then I can do the same thing for my storage coefficient. And so for this one, I'll just take off the divided by 2, for example. Hit calculate, and there we go. All right, I apologize. I had a nice little equation ready to go that was all official and everything, but that happens, I guess, with live demos. All right, moving on. We have 2 more here to quickly parameterize. The next one will be base flow. And so for this demo, we're going to be using linear reservoir base flow. And this is the only base flow method within HMS that conserves volume. And it's one that we typically like to use. It's applicable for kind of a wide variety of scenarios. Bear with me here while I get this entered in. You'll notice on the bottom here that this is also hooked up to the expression calculator. And so if we wanted to, we could go in and parameterize that with using the expression calculator. But for this demo, I'll just quickly enter in some of these values here and get them filled down. All right, and that leaves us with our last parameter, and that's going to be linear reservoir. I'm sorry, that's going to be our lag routing reach. So we're using the lag method. This is definitely the most simplistic method in HMS. It's not typically recommended. It's usually only applicable to very steep channels with little to no storage. But for this example, we're gonna use it. It does the trick, and it's quick to parameter. We got that parameterized. And before I hand it back off to Tom to show off the cool auto forecast feature, I'm going to just quickly kind of recap a few of the high points that we just touched on. All right. So a few of the key points. The global editors can be used in tandem with the expression calculator to quickly initialize your parameter estimates. And the two types of data sources that the expression calculator is currently able to access are characteristics that have already been computed and parameter grids that have been imported into HMS. There are two ways that you can kind of export GIS layers for analysis outside of HMS. One is through the Gis Export Layers menu, and we've again added several different layer types that you can now export as shapefiles. And then secondly, that Basin SQLite file is where a lot of that geospatial data that you see in the map pane lives. And so you can take that SQLite file and view it in an outside GIS software of your choice. All right, and with that, Tom, I'll let you take the reins.
Tom, you're still on mute. You on mute real quick?
I was on mute. Got me. All right. So we started from scratch. We delineated a basin, and then Josh just showed how to parameterize that basin. So from here, the last thing that's left to do is to actually run a simulation. And in past webinars, we've showed how to bring in some data and set up the simulation. This time we have a new feature called the auto forecast, and so it automatically pulls in data for us to run a forecast. So I thought, why not demonstrate that as a way to show precipitation and temperature boundary conditions over our basin. So I'll go through that demo real quick, and we'll see if we can get a forecast to run. So I'm going to go to the Compute menu. I'm going to select Forecast Alternative Manager. I'm going to select the Auto option. So this is for the automated forecast, and there's a wizard here. We're going to make a few selections. So first, it's to provide a name. There's a default name that's provided that's based on the current time, which is 11:49 on the 25th of May. So if you can name it whatever you want, but the default name is kind of handy just to let you know when you computed the forecast. Next, I'm going to select a basin. So the basin I'm using here is the only one that we happen to have in this project, which is Denton Creek. Now we're getting into the data part. So we have to select data for a look-back period. Forecasts include both a look-back period and a forecast period. And so for our look-back period, I can specify a duration in days. And I have limits on the duration anywhere from a 7-day look-back period to a 30-day look-back period. I'm going to use 14 in this example, and then I can select data sources. I'm going to use real-time mesoscale analysis you'll notice there happens to be one data source. This is kind of the first cut, and real-time mesoscale analysis is one of the best data sets out there for a look-back type analysis. And so that's what we have initially, not to say that we couldn't add more in the future. And on the fourth step of this wizard, I have the opportunity to select some forecast data. And we see the products here. I have high resolution rapid refresh from 0 to 0.75 days, so 18 hours. North American mesoscale model from 0 to 3.5 days. And then global forecasting system from 0 to 16 days. So I'm going to go ahead and start running the import. And you'll notice that when I selected forecasting data, there's a handful, there's more than one option. And so what this tool will do is it will actually layer and stitch together those data sets in order of precedence. So the higher resolution data sets are going to have precedence over the coarser data sets. So that her data set that goes from 0 to 18 hours, that hourly time step is going to have precedence over something like GFS that might be at a coarser time step. So what this is actually doing, this is actually reaching out to a server and running commands on a server to retrieve this data. And right now we're retrieving RTMA, and you saw it just jump to her data. So we went from the hindcast period to the forecast period. Now we're retrieving the North American mesoscale data, and now we're retrieving the GFS data. Now it's actually importing it, so we downloaded it, and now it's converting it to the HEC DSS format so that we can use it in HMS. So it's going through those steps now. It's actually going to retrieve flow at the 2 gauge locations. So it's done that, and it just ran a forecast. So we just ran a forecast. Let's see what kind of rain we're going to have in Dallas and Fort Worth here soon. So I did a little bit of a course calibration. It could probably use a little bit more, but you can see we have that 14-day hindcast period here. There's a forecast time in the middle of this plot here, and then we're running into the forecast period, which is going all the way out to the 8th of June. So we just went from nothing to a forecast simulation in 50 minutes. So let's see, I have a few key points on auto forecast. I'll hit those, and then we can take whatever questions are out there with the time remaining. Let me pull up the key points. Oops, let me try that again. All right, so the key points on automatic forecast, it pulls in data for a look-back period and a forecast period, and you can specify the duration of that look-back period. The data is layered in order of precedence. So like I said, higher resolution data sets will have precedence over lower resolution. And then one thing I didn't mention is that currently we only have CONUS data sources implemented, and that's those are the easiest for me or for us to access. There's definitely data sets that are international that I'd love to add in the future. Some of them are harder to get to, some of them require fees and things like that. But that's something if you're international and have ideas on data sets that might be helpful for your area of the world, feel free to reach out and let us know. And then the Basin model must use continuous simulation. You notice that I use a look-back period of 14 days. I can go up to 30 days, which is really helpful for setting those initial conditions. That really eliminates what might be happening in initial conditions by doing a full continuous simulation. So that's one of the, I would say, the features of this tool is that it makes continuous simulations for forecasts pretty easy. All right. So what I'll do, I'll go to the end slide here and then kick it over to Mike, who I think has been monitoring the chat and can toss us some questions with the time we have left.
Yeah, thank you, Tommy. Sorry, I had to change out my AirPods. They don't hold a charge like they once did. Thanks, everybody, for the awesome questions in the chat. You guys are, it's awesome to see that as many people are pumped up about these features as I am. First time Tommy showed me GIS features, my jaw hit the floor. By the time I picked that back up, Josh was showing us build walls, burn streams, and characteristics, and my jaw hit the floor again. Picked that back up, and then Tommy showed us the auto forecast feature, and I still haven't picked my jaw off the floor. So I think everybody else is as stunned as I am when I first saw those things. Very cool stuff. The links that are shown here excellent resources. A lot of people were asking, hey, can you give me some way to summarize this information or a quick way to go back and look over it? Please check out these links. They are very, very topical, and we keep them up to date. We spend a lot of time updating documentation. We don't release stuff without providing documentation. And also, we don't release stuff anymore without providing tutorials and guides that goes through it. So check out that specific link right there in the middle, the top middle, the HEC HMS tutorials and guides. There is a tutorial and guide for nearly all features. Tommy said we might have a couple in there that we still want to do, like how to merge and mosaic terrain files and prep things for import to HMS, but we're getting on that. If you are interested, please call us and reach out to us if you think that there should be a tutorial and guide that is not there. And we're working with as many people as possible. It doesn't even have to be within USACE to contribute to this material. We have international users that are providing excellent resources in here that others can look at and use as well. So we'd love to have your contributions there as well. Videos, we've been putting a lot of time and effort into them as well. We have links to basic HMS class materials, so we've tried to split them up into 5, 10, 15-minute chunks, and you can see the ones that Tommy has shown here. So if you're interested in starting from scratch and building a model, there are a set of videos for that. They link in well with the tutorials and guides as well, so we'll go back and forth between them. If you're interested in discussions about model discretization or calibration steps, there are tutorials and guides and videos available for them as well. If you can't find something that you think should be on there, please send us an email. We're interested in discussing with you as well. With that, I do have some questions that would be really good and topical to discuss. We're not going to get to everything. I'll just throw that out there right now. But if we don't, either send us an email or we'll email you with specific questions. Dino had a really good one, Tommy, for you. He's using MRMS and RTMA data from the Iowa State website. So that natively has a different resolution than 2,000 meters. I think the MRMS does. And he wants to know, what discretization size should I choose, 2,000 or 1,000 meters?
Yeah, so that's something that's in flux, and HMS is getting more flexible and capable for handling those different resolutions, which is really cool to see. You certainly can use a higher resolution, resampling down to 1,000 meters. It's not necessarily going to get you a whole lot unless your Basin model is also using 1,000 meter discretization. So if you're a pretty small drainage area that you're modeling, and you think that 1,000 meters is merited, by all means, you can do that. So you could sample your precip down to 1,000 meters. You could use a discretization that's SHT 1,000 meters. And then I'll say one of the cool things about, I believe it's the 4.9 beta series, is now you can actually mix and match resolutions for met boundary conditions. So if you wanted to use that 1K grid cell size for your precip, you could also use a 2K or 4K size for your temperature data. That wasn't possible in previous versions, but now you can mix and match those, and HMS will rectify everything when it goes to compute. So not necessarily going to make, using that different temperature resolution isn't necessarily going to make the biggest difference on your compute. It might, but if you have a really big data set or you're passing data around, it might help to lighten the load, at least on disk.
Nice. Yeah, I thought that one was super topical. You just did, we're demoing that feature, the different resolutions, last week to us. And again, it's all on the floor. Got some good questions about forecasting. I think you blew everybody away with that one. Folks were asking, Josh, you had mentioned this earlier. In addition to calibrating your initial moisture conditions, given your look-back period and observed data, you can also import TIFs of moisture from, say, MODIS and sample from that, correct, in the expression calculator?
Yeah, so absolutely. I don't know, Tom, there are 20 different types of grids now that you can import into HMS. And I think it accepts, does it GeoTIFF, ASCII, and DSS format, is that right?
Yeah, right now we kind of have it set up to accept the common formats being GeoTIFF and ASCII. So if that MODIS grid whatever format that comes in, it might be NetCDF, I'm not sure, but you can certainly get it configured into, if you can get it to a GeoTIFF or ASCII, then we can sample from it and that expression calculator. So that opens up, I know, like we use, MODIS would be I think it's a great source. It's pretty near real time for current soil moisture state. And I know a lot of people out there are using NLDAS that has like a similar product. So it's cool to see if you guys are using those type of products, just like it's cool to see what you are doing. And so showing that to us is awesome. I think we're trying to build really flexible tools to work with anything. And there's no limit really how you can apply it.
I'll kind of follow up onto that, saying that, you've heard us mention the tutorials and guides quite a bit. We're like actively looking for districts and you folks that kind of know how to do some of this stuff. If you're willing, to put together a tutorial and guide on how to use MODIS data and use that within the expression calculator, that'd be great. There's MODIS, there's Sergo, there's bunches of different sources, different ways to do things. But I do think a tutorial and guide would be helpful for others trying to figure out how to do this kind of stuff.
Excellent point. All right, I want to be cognizant of everybody's time, so we're going to go ahead and call it there. Last thing that I wanted to share, I'll take control here real quick. Folks are asking, where can I get the newest version? On our website. If you go to HEC HMS under software, there's a downloads link as well. And in here, you're going to have access to the latest beta. So it looks like Tommy just posted the newest beta 2 for HMS 4.9, so that's available. This is admin free. You do not need admin rights to use this. So it's not going to be an app portal. We don't push betas up there. If you want to get the latest and greatest beta, please grab it from our website. Also, if you want to grab any past release, go ahead and grab them here. The first link is going to be for the classical install package that you'll need admin rights. But anything that's listed as portable, you do not need admin rights access to that. So go ahead and grab those ones. If you're interested in different operating systems like Mac or Linux, those are available there. We'll have some new features coming to all 3 versions in short order. So with that, any closing remarks from Josh, from Tommy? You guys have anything else? Great comments from everybody.
Yeah, that was fun. Always fun to go through that, and I think it's really cool to see like the little improvements we're making to the GIS tools. So I know it's to some people it might look similar to previous presentations, but hopefully you picked up on the few new features that are just streamlining that workflow, and we're going to keep on adding those as we see fit.
Excellent. So thanks again, everybody, for attending our second HMS Quarterly Webinar. We're going to have 3rd and 4th and 5th and 6th. As long as we keep having topics to talk about, we'll keep doing these as well. If we didn't get to your question, please send an email. We'll respond as fast as we possibly can. So just a reminder that the PowerPoint presentation and a video recording of the webinar, we're going to post those to the website soon, so stay tuned to that. We'll send a link out to those materials for everybody that's on the HMS email list. To be added to the HMS email list, check out our website, software HMS, and then email list. And you'll be able to send us an email saying, hey, I want to be added to this list. We'll be able to hit you up that way. So with that, thank you, everybody. I hope you have a good rest of your day and stay safe.